Okay, in this sample problem we are going to be solving a homogeneous differential equation for y. And okay, when I say solving it for y, we're actually just going to solve it. We're going to get an equation, and it's not going to be y equals because it's going to be a messy world. And the first thing you need to do when you look at homogeneous functions, x squared, y squared, and 3xy are all degree 3. And if you have degree 3, and then you have m of xy dx plus n of xy dy, meaning you have some sort of equation in terms of x and y, here and here, then you can replace y with vx, where v is some function of x, and we can replace dy with x dv plus v dx. And that's just because v is a function of x. Product rule, x times the derivative of v plus v times the derivative of x. Okay, so I'm going to go ahead and substitute these: x squared minus v squared x squared dx plus 3x squared v, because that's x times vx. And then here it's going to be x dv plus v dx is equal to 0. Now I'm just going to group all of the dx terms, which when we get done with it, it will be x squared, and this is 3x squared v dx minus v squared x squared, so that'll be plus 2 x squared v squared, and this is all dx. And I'm just checking to make sure I've got that right. I do. Plus 3x to the third v dv is equal to 0. Okay, we're doing okay so far, but what I'm going to do is factor out an x squared. 1 plus 2v, did I do that right? I think so, 2v squared dx plus x squared times 3xv dv is equal to 0. Now, the x squareds cancel out, so I'm just going to rewrite that now without that's a squared term there. So it's going to be 1 plus 2v squared dx plus 3xv dv is equal to 0. So I will, through the magic of an eraser, if I can work this right, I'm going to erase this 0, erase that equal sign, erase that plus sign, and I will replace it with an equal negative. So now I have I have dx on one side, and I have v's on the other side. So what I'm going to do is divide both sides by 1 plus 2v squared and divide both sides by x. So I should get 1 over x dx is equal to negative 3v over 1 plus 2v squared dv. See what I did there? We now have separation of variables. Now if I integrate those, natural log of the absolute value of x, and over here I get negative 3/4 natural log 1 plus 2 v squared plus, well, it's c, but I'm just going to write it as the natural log of the absolute value of c because that's a constant as well. Now this integral, if you look, if this is u, 1 over u, we have to put a u prime up here, so you have to put a 4v up here. So if you have to put a 4v up here, you have to put a 1/4 out in front. That's how that integral came about. Now I'm going to multiply both sides by 4, and this actually is an absolute value as well. I didn't write that very straight. So we have 4 natural log absolute value of x is equal to -3 natural log 1 plus 2 v squared plus natural log absolute value of c. So what I can do now is bring my exponents up. So this becomes natural log of x to the 4th, and I can get rid of the absolute value because x to the 4th is always going to be positive. Then over here I can do, because this is plus natural log absolute value of c, I can do natural log of the absolute value of, I want to make sure I get this right, c times 1 plus 2v squared to the -3rd. And we have an absolute value sign there. Now, because it's natural log is equal to natural log, I can just now say x to the 4th is equal to c 1 plus 2v squared to the -3. And I'm going to go to the next page here, and I will just rewrite what we had. X to the 4th is equal to c times 1 plus 2v squared all to the -3rd. Now, I can get rid of the absolute value over here because x to the 4th is always positive, so this always has to be positive, therefore I don't need an absolute value. Now, remember that we said y is equal to vx, so v is equal to y over x. So x to the 4th is equal to c 1 plus 2 times y squared over x squared to the -3rd. So I guess we could stop there if we wanted to. What the book does is they solve for c, and they have x to the 4th times 1 plus 2 y squared over x squared to the 3rd is equal to c. And because this is -3, when you divide by -3, it becomes 3. And so if you want to get rid of this x to the 4th and go through, if you make this x to the 6th, you get x squared plus 2y squared to the 3rd is equal to c x squared. And what I did there was I took this whole equation and multiplied it by x squared. So this is cx squared. This is x to the 6th. Well, x squared to the 3rd is x to the 6th. And if you put x to the 6th in here, that is x squared divided by x squared. So that works out. If you want me to go through and explain that in class, I can. But this is the process that you go through when you have a homogeneous differential equation and you need to come up with the solution. And what you'll notice with the solution, I'm going to circle it in blue, the solution is an equation. It's not a y equals. If you had to solve this for y equals, you would end up with a pretty crazy radical, and you'd have to do a plus or minus because this is not a function of x. It's a function of x and y, which means the phrase that we would use in class so far is it would be an equation, not a function. When you get further into three-dimensional equations and functions and so forth, you'll have different definitions, but for the purposes of our class, this is where we're going to stop.